Well, hello everyone and welcome to our project, No Fire Now. My name's Luke and with my team, Dar, Jamie, Jonathan, Shane and Timothy, all from the Gold Coast, we've come up with a potentially life-saving project that is involving the use of a smart smoke detector. Alright, so the way our system is designed is that there will be two parts to the sensor side. So there will be sensors placed out into the bush, and their role will be to communicate back to the open data sources the information such as temperature, light, humidity and the presence of smoke or not smoke.
So here we have an example of how the light sensor is being suffocated for light, and it takes a moment, but it will come through on the website. So if we look at the analytics dashboard on the left there, you'll see that the blue line has dropped to the bottom, indicating a lack of light on that node.
And once this information has been established, we will be able to use wind speed and wind direction to establish what direction the fire is likely to travel in. And then, once we know the direction, we can then inform any smoke detectors that are in houses of the location of the fire and trigger those smoke detectors so that those people know well ahead of time that there's a fire near their house. So normally a fire would need to be X distance from a house before the smoke detectors would go off. This would have the smoke detectors going off 1 to 2 kilometres sooner. That's got to provide more time, and in these situations, either in fighting the fire or in running away from it, you're going to need more time. More time will equal more chances of survival. The technology being used for this project includes a low-cost microcontroller, being an Arduino. There is low-cost sensors for temperature, humidity and light. The wind speed and wind direction are not cheap sensors to make, so wherever possible we'll be sourcing that information from the Open Data Portal. Alright, so I'm here with Jamie, who's one of our lead coders, and he's here showing us the data from the Darwin City Open Data Portal relating to IoT. So what we're observing here is the location of the nodes at a geographical level. You can see that the information provided is temperature, wind direction and humidity and wind speed. We can look historically through the data, so you can see that there is a different value for the following day. And the status of the nodes is indicated by their colour, so you can see the two that have just turned red indicating an alert status. The importance of this program is to get the message about fire out to the people sooner. The ability to know about the threat sooner is the ability to make a faster decision about whether you're going to fight the fire or run away from it.